Hello, everyone, and welcome to our webinar on generative AI in finance. My name is Michael Willis, and I'm the director of the Executive Master of Accounting program at the University of Cambridge Judge Business School. Often, when people hear Executive Master of Accounting program, they think, I already know accounting. Why would I want to get a master's degree in it? But the truth is, our program is unique. It's one of a kind in the world, and it's not a program that's designed to teach the technical fundamentals of accounting. The Executive Mac program is a leadership program for professionals in accounting and finance, and it's designed to accelerate your career to senior levels with training in very important and timely topics like change leadership and strategy and sustainability and data analytics. Many of our students have strong backgrounds in accounting, chartered accountants, CPAs, etc., and in finance. And they find that our program is very complementary and additive to what they've learned. At the end of the webinar today, I'll say a little bit more about how to learn more about the program and connect with us. But the purpose of this session today is just to give you a very small taste of the kind of thing that we cover in the Executive Mac program. So our speaker today is Dr. David Stillwell, who is a professor of computational social science at the Judge Business School. And very fortunately for us, he's the instructor of the predictive analytics module in the Executive Master of Accounting program. So all our students take this module from Professor Stillwell. And this is a really important piece of our curriculum because many of the technologies that we label as AI are based on predictive algorithms. And in David's module, our students learn how these algorithms work, and they actually build and run these algorithms themselves using real-world data sets. So it's really exciting what David does with our students. And David, thank you so much for taking the time to be here, and I'll turn it over to you.
All right, great. Thanks so much, Mike, and thanks for joining us, everyone. Just to say, you should have this Q&A box somewhere on your Zoom screen, probably at the bottom. So that's what I'll be trying to monitor in terms of questions and comments as we go through. So feel free to take advantage of that. But I'm going to jump into the content. So let me do the classic meeting thing and share my screen. So there you go. I'm going to talk about generative AI specifically in this session. Well, I'll talk about the difference between generative AI and machine learning in a minute. But I wanted to start with this picture in the background. Just have a look for a second and think about if I ask you to guess, where would you say this picture is taken? Like, what is this a picture of? So I asked this to, well, basically anyone who comes to Cambridge, and I'm talking about AI. And they'll guess, oh, it's a picture of King's College. It's a picture of thanks, Reese. Straight into the Q&A box, King's College. Great guess, yes. Or they'll say, is this a picture of the University of Cambridge? And then, someone sort of clever will pipe up and say, oh, it looks like it's an AI picture. And I say, yes, it is an AI picture. But what did I ask the AI for a picture of? Right. The reality is I asked the AI, so this particular one was Midjourney. I asked it for a picture of University of Cambridge Judge Business School. In other words, the place where I work. Now, if you haven't been to Cambridge before, you may look at this picture and go, Cambridge University Judge Business School looks like a nice place to work. However, it doesn't look like this. So this is what Cambridge University Judge Business School actually looks like. It's not quite like the picture that the AI has generated. I have to say it's still a nice place to work, but it's not this kind of architecture. And what I find fascinating, why I share this example, is because it kind of, it has the feeling of Cambridge University Judge Business School, right? Like, if you'd never been here before, and I said, hi, I'm David, I work at the business school, here's a picture, you'd probably sit there and you say, yeah, fair enough. Looks like that could be Cambridge University Judge Business School. So it has the feeling of Cambridge, right? It's got these yellow bricks, this Gothic architecture, the grass in square shapes, but it doesn't match the facts of Cambridge University Judge Business School. And this is kind of, I start off this talk about generative AI because for me, this distinction, this fact that it shows us things that feel like the right answer but are not necessarily factually the right answer, is both really interesting, but it's also really important when it comes to using this technology in business. Right, so this is an AI that is giving me an answer that feels good, but is not factually good. So why is that? Like, why is it doing this kind of stuff? And it's not matching the algorithms that we're used to, right? When you use a calculator, you put your numbers into the calculator, and as long as you press the right buttons, you get the right answer, right? There's no randomness, there's no equivocation. If you press the same buttons next time, you get the same answer. So, and that's what we're used to with computers, right? Computers are factual, they're logical, they're systematic, they're like calculators. But this is an AI that is giving us something that feels like the right answer, which is different. And the difference is important because when it comes to using this stuff in the real world, I think people need to have the right mental model about what actually is generative AI. Like when I ask ChatGPT a question or Gemini or whatever, Claude, what's it actually doing? And therefore, what kind of mistakes might it make? What do I need to look out for? What could go wrong? So here's what I'm going to talk about. I'm going to start by talking about the current landscape of generative AI. Talking about some of the capabilities and way that it's been deployed in finance. And then I'll talk a little bit about how do they actually work intuitively. Now, as I say, like frequently you see like individuals or companies that have used Gen AI. One example was there was a lawyer that used Gen AI to write their legal case, and it just made up a bunch of references. There was also the case recently, I think it was Deloitte that got Gen AI to write, or at least got some AI to write a report for the Australian government. And again, it turned out it made up some of the references. So we've got all sorts of professionals using this technology and being surprised when it doesn't work the way that they expect. So I think you need to have an intuition about what's actually going on to help you realize what could go wrong. What do I need to look out for? Now, extremely briefly, this is a talk about generative AI. It's not a talk about machine learning. As Mike said, we do some machine learning on the Executive Master of Accountancy. I think it's great that you can kind of jump in with it. We've also in the last few years worked with students and allowed students to use generative AI as part of that. So, I mean, there's no need nowadays to write all the machine learning code, by hand and deal with all the syntax errors and all the rest of it. Now you can work with generative AI, which brings down the barriers to people who are not computer scientists, they're not software engineers, to using these latest technologies and applying it to their area of interest in accountancy, finance, whatever, or in my case, in academic research. But machine learning and generative AI are different. And the trouble is when a startup or a company says, oh, we use AI, like we've been talking about this technology for so long that it's become a total mess. Like, if someone says they're using AI, what are they actually doing? It could be that they're using, large language models. It could be that they are doing machine learning. It could be that they are, they've got some kind of algorithm that says, if this happens, then do that. There's a lot of that kind of stuff going on. And this is important because these technologies are fundamentally different from each other in terms of their use cases, in terms of what could go wrong. Now, Arbes, thanks in the Q&A. So the whole is divided into these three main categories. So here I would say you've got different machine learning algorithms. So deep neural networks are the algorithm that's really kind of pushed machine learning forwards in the last decade or so, and it's achieved things that we weren't able to achieve with other algorithms. But there are still many other machine learning algorithms. Some of them are easier to get an intuition about what's going on than others. Deep neural networks are very good at making predictions. They're not very good at telling us why they've made the predictions they make. So there are many other algorithms. So they make up machine learning, and machine learning is part of generative AI, but it's not the whole. I think when it's acting like a human, think of a chatbot on a website. So you might have some machine learning predicting, what should I say next? But in order for it to feel sort of intelligent, you've got all this other stuff going on around it, right? You've got, you're giving the chatbot some context about what it's doing. You're telling it what not to do. You're telling it, the kinds of way that you want it to speak, whether it has a name or not, those sort of human sides. You're perhaps giving it access to a database so it can get information, or maybe the ability to update the information. If someone says, I want to cancel my flight, can it actually go to the database and cancel it? So there's a lot of extra stuff around it that makes it intelligent, not least of which is that flexibility. So if you think of an intelligent person, think of the smartest person you know. If you gave them a task that they'd never done before, then a really smart person, you would still have confidence that even though I've never seen them do this before, I bet they would do a good job. And machine learning isn't like that, right? Machine learning is you make an algorithm to predict the weather. You make an algorithm to predict whether a bank transaction is fraudulent. You make an algorithm to predict if someone's going to repay their loan. And that's all it ever does, right? There's no point asking the fraud algorithm to predict whether someone's going to repay their loan, because it's got no idea. It doesn't do that. Never mind, it won't write you a poem or summarize your email or whatever. So machine learning doesn't have that flexibility, but Gen AI, the likes of ChatGPT and Gemini, you can ask them all sorts of questions. You can ask them questions that no one has ever asked before. You could say, write me a poem about the difference between the University of Cambridge and a watermelon. And no one's ever written that poem before, but I bet it would do a good job. So it's got that flexibility. All right, now a little bit more about the context. So as we know, there's been incredible excitement about this technology almost immediately. So whereas it took Netflix 10 years to get 100 million users, it took Instagram 2 or 3 years, it took ChatGPT 2 months. So it came out November 22. By January 2023, it already had 100 million users. So immediate excitement. If you're wondering, well, how does that compare to the internet? I mean, ChatGPT, you can see how long, a couple of years before it got 800 million users. The internet took 13 years. So the pace of change is blistering. Now, what about where's it going, right? Change is happening, but where's that change going? So this is a page from a textbook called A Brief History of AI, which was published in January 2021. So this was about 18 months before ChatGPT came out. And you can see at the bottom of the page, you've got a list of nowhere near solved problems in AI at the time. So you've got understanding a story and answering questions about it, human level automated translation, interpreting what's going on in a photograph, writing an interesting story, interpreting a work of art. These are nowhere near solved a couple of years ago, right? And so far so nowhere near solved that even the person writing the textbook is saying, like, we don't even know how to start going about solving this problem. But all of those problems have been solved now. The only debatable one is human level general intelligence. So my point here is that even this expert, like literally the person writing a textbook history of AI, has been surprised by what's happened in the last few years. And that's still the case in my experience. So We work with people here in computer science in Cambridge. We work with people in Microsoft Research, for example. And if you ask them, what's going to happen in a year's time in AI, they kind of laugh and they say, I don't even know what's going to happen in 3 months, never mind a year's time. So the pace of progress is, the pace of change is fast, and the pace of progress and where it's going, like what's going to happen next, is unknown, not just to um, non-experts. Like if you're sitting there thinking, I don't know where this is going next, but someone does. No, no one knows where this is going next because it's changing so fast. Right now, um, uh, I want to talk about the types of capabilities that are out there now and show some of the things that have happened in the last couple of months in terms of latest capabilities. I'm going to do it at a broad level, right? So this isn't a talk where I'm going to go into, here's the latest tool for doing some specific thing. Um, but at a broad level, what capabilities does Gen AI give us? So, I mean, first of all, there's obviously language, right? Lots of language models. And I say lots of language models intentionally because for me, they're largely becoming commoditized. Um, Now, I may look ridiculous in 5 years' time, but at least where I'm sitting now, um, I don't see absolutely massive differences between the models. Now, that's not to say that if you're really pushing for some advanced capability, that you won't find that one model is better than another. Um, they're also they're improving on each other. So it looks like one model's the best, and then the next company has their latest model, and that looks like the best. So there's that going on as well. But broadly, even today, I would say, if you're doing the kind of um, relatively, I mean, it's not simple, but sort of the things that you don't need someone with a PhD to do. If it's like I want to, make my email more professional or summarize this long document, then, for me, it largely doesn't really matter which model you used. So for me, they're becoming relatively commoditized. Um, Personally, I think that's good for those of us who are using AI rather than building AI. Um, because of course, if one of them is way better than the others, then we have to pay the price for it, right? If they increase the price, then they're in a powerful position and we have to pay. But you can see what's happened. There was this great chart in the FT. So in 2023, 50% of companies' money was going to OpenAI. By 2024, it's down to a third, and I would be surprised if it hasn't decreased further in 2025. That's not because OpenAI is necessarily getting worse or the others are getting better. It's just because there's so much choice. So you're not stuck with one provider. Reese, what you're asking in the chat. So, what's the difference between closed source and open weight? So, great question. So, you can see those four at the top are the closed ones, and then we've got various open weight models at the bottom. Essentially, with a closed model, if you've got your question, then you send it off to ChatGPT or Claude or Gemini or Grok, and don't forget, your question might include confidential information, right? It might be analyze this document, or here's an email I received. Can you summarize it? So you send that to the third party. They then analyze it and send back the result. So you've got at least two risks there. One of them is contractually, what do they say they're going to do with our data? And second is, even if they say they're going to not use our data for training their models, for example, what happens if there's a cybersecurity issue in the third party and my data gets out there, gets stolen? With the open models, once the model has been trained, then all of the weightings, which are the numbers in that algorithm, so all of those numbers are made available. So you can then download them, install them wherever you like. So it might be your own infrastructure on premises. It might be private cloud. It could be wherever. And in that case, you're only sending your data to, your own infrastructure. Now, the good side of that is you've got no third parties to deal with. The downside is that now you're responsible for your own cybersecurity. Now you've got to set up all the infrastructure and make sure it's working fast enough, and that when you ask a question, it answers quickly and not 5 minutes later. And you're also responsible if you want to keep updating the models. You might have to download new things. So there are kind of your options with the open versus closed models. Now, there was also another trade-off in the past, which was that the closed models were much better than the open models. So if you asked a difficult question to a open model, you get a much worse answer than if you ask it to a closed model. But you can see on this chart that the difference between them has been decreasing, decreasing, decreasing until one of the surprises with DeepSeek in January last year was that it's an open model that is as good or was as good as the best closed models from companies like OpenAI. So essentially, the closed models have largely caught up with the open models. I think the piece of research I saw recently said the open models are about 4 months behind. So if a model comes out today with better capabilities than any other model, in 4 months' time, you can expect an open model that reaches the same kind of capabilities. So there isn't the trade-off really when it comes to quality of responses. All right, now we've all seen the language generation. There's also image generation. So again, there are many options to choose from here. This is 18 months of progress on Midjourney with the same prompt. So you can see in version 1, it was generating something, but it wasn't a great picture. But things got better and better and better and better and better until nowadays it can be hard to tell the difference between an AI image and a real image. But yeah, so that's 18 months of progress. So if you see, some AI capability and you sort of trial it and, you're getting the version 1 and you're kind of looking at it and going, well, this isn't really good enough right now. My advice is, don't dismiss that and say, oh, AI's got a long way to go. Just realize it probably won't be long before it gets to a level where where it is useful and where you'll be surprised. Now, this kind of image generation, I mean, Klarna made a big deal a couple of years ago about using it to reduce the costs of their marketing campaigns. What I liked about this is the article said, well, it's not just about reducing costs, it's also about increasing the output of what they do. So, for example, they can put out images for Valentine's Day and Mother's Day and summer sales and this kind of thing. Whereas previously, you have to go through a whole process and it's quite expensive. So you reduce the number of times that you change the images and, maybe you only do it for Christmas, but nothing else. When you reduce the time and the price and the effort, then you can, produce more images and use them. You could sort of describe it as like a higher quality, right? Like the images are more relevant for the users looking at them that day. Here's an example just to show. I mean, I said earlier, it can be hard to tell the difference. So here are two pictures. One of them is real and one of them is AI. Any idea which is which? You can write in the Q&A box if you like. Which of these do you think is AI and which is real? All right. Rinal says the right is AI. Someone with many letters and numbers, D501844D, says the left is AI. So a few more people, right, left is AI. All right. Thank you. So, I mean, it's hard to tell from the Q&A box. I mean, I think it's like 50-50. People as a group, you've got no idea, if that's fair to say. Um, I'll give you the answer. So the one on the left is AI, and the one on the right is real. Um, so if you've looked at AI images, about a year or so ago, you may have seen like, oh, the way to tell if something is AI is like you count the number of fingers, and AI puts too many fingers on one hand. Um, or it does other weird things with teeth, right? Like there are too many teeth when someone's smiling. Um, this kind of thing is largely gone away. So the only way that I can tell this one on the left is AI is because you've got TEDx and then the name of what should be a city, but there just isn't a place with this name. So it's messed up the text. But in terms of what she looks like, um, I couldn't point to a particular feature and say, well, that's how you know that she's AI. Um, now, as I say, this was about a year ago, but last April, models came out from Google and OpenAI that also solved the text problem. So you can generate adverts with text on it fine now. They also allowed you to use an image as part of the prompt. So you can say, here is a woman, here's a jacket, create a picture of the model wearing the jacket, right? And it's put those together. So you can quickly imagine what shopping would look like in the future. There's just a picture of you, and then you choose out, different pieces of clothing, and it shows you in the whole outfit. Um, uh, so, well, and this is the last bit I wanted to show, because so this came out in December, a model from China, and that produces the layers. Right. So if you know anything about graphic design, you know that graphic designers, they don't necessarily really want the final image. They want the separate layers so that they can make edits to the whole thing. And now, there's an AI model that produces the whole set of layers. So the thing I want to emphasize here is, the AI sort of slowly improves, but at some point, it reaches these thresholds where it suddenly becomes useful, right? Maybe a year or so ago, you'd say, well, this image generation is sort of nice, but there are too many fingers on the hand, right? I'm not going to use it. Or the text is all messed up, so I'm not going to use it. Or, I need to have layers, so I'm not going to use it. And so, you pass these points where suddenly, for a graphic designer, suddenly this stuff is useful in the real world. Now it's also useful for bad things. So remove the watermark on the left, or create this fake receipt, right? So now that it can do text, very useful for marketing. Turns out it's also useful for creating fake receipts. So you've got the receipt. It's sort of a bit crumpled. It's got the shadow of the phone taking the picture of the receipt here. So looks pretty compelling. Now, as I said, this was about April that this capability really came through. By October last year, 10% of CFOs in this survey are certain that AI had been used to generate fake receipts in their company. And about 60, 70% of them were, kind of pretty sure that AI had been used. So again, that shows something about the pace of progress, both in good things, but also in problematic things in terms of misuse or abuse of AI is also happening quickly as well. Now, here's another example of those capabilities. So this is video generation. Again, this is Runway version 2, which was the first one that was kind of released to the public. And this is one that came out a couple of months ago, version 4.5, and the same prompt. And you can see that, the man running in the park holding an apple was not very good in version 2. But by version 4.5, we're getting really quite high quality videos being generated. So I won't quite say that video generation has been solved, but it is very much getting there. Here's another example. So in Google's latest model, it does the sound as well. So not just the video in the background, but does the noise happening. Now, I should warn you, I've got quite a dark sense of humor, so I find this funny. But let's see if you find it funny as well.
Live at the sinkhole on 4th Street, which unfortunately has already taken the lives of 2 individuals. Correction, 3 individuals. You can see water levels are rising after the storm. We lost another one.
Today, we're looking at the city's ongoing efforts to repair crumbling infrastructure. But as you can see, some issues are more apparent than others.
Authorities are urging residents to avoid the area entirely. As you can see behind me.
Today, we're on Elm Street examining the city's ongoing efforts to address critical infrastructure issues, like this rather large pothole behind me.
All right, so you know, you can see this stuff getting better and better. It's got the sound to go with it now. In case you're wondering, like, who can tell the difference? So I think when it comes to videos, humans can still tell that a video is AI generated. You know, if you look at it sort of seriously and closely enough. Algorithms can also tell. When it comes to images, humans, other than the very best experts, humans struggle to tell the difference. But AI can still tell the difference. So you can still have an algorithm that detects this is a fake receipt or very likely to be a fake receipt. And it's pretty much close to 100% accurate. When it comes to text, like, you know, writing a report or an email, both humans and AI can't tell with anything close to 100% certainty. So although, you know, you may sort of feel like, well, I've seen this kind of AI stuff and I can tell that it's AI. When people do tests, it's difficult to tell, especially if the person's using AI in a more sophisticated way. You know, if it's not just write me an email, but a bit more write me an email in a human way, here's some examples of my emails, write it in my style, then it gets around both the humans and the AI detectors. All right. The next one is going on to avatar creation. So this is about creating videos of actual people. Now this is a video of me. It is entirely AI generated except for the slides. So it's my slides, but the things that I say and the audio and the video of me actually saying it is entirely AI. So I'll just show this for 30 seconds or so.
Let's begin with a foundational concept in generative AI, generative pre-trained transformers, or GPTs. These models are generative because they create new data that fits within the patterns of the data they've been trained on. Ils sont pré-entraînés sur de grandes quantités de texte, ce qui leur permet de comprendre la structure du langage, en prédisant les mots manquants dans les phrases. Cette étape est...
Okay, so you get the gist. So now in order to generate this, I had to stand in front of a green screen for about 15 minutes, answering some questions so that it could learn my mannerisms and the way that I speak. But AI nowadays, OpenAI say they need 15 seconds of someone's voice in order to recreate their voice. And they need, and I've seen a Chinese company that just needs a picture of you in order to recreate, you know, the video of you speaking. So what I'm saying is, you know, if there's 15 seconds of someone speaking and a picture of them on the internet, then anyone can come along and create an avatar of them and get them to say whatever they like, right? So you can think of immediately kind of bad use cases of this kind of thing. In, you know, how might it be used to scam companies, to pretend to be people, to try and get access to systems, for example. And, you know, potentially you can think of some positive uses as well. So UBS, for example, last year said they were using these clones to create more video format research. So apparently there's a demand from clients to, you know, see this research in video format. I don't know, maybe it's something they can listen to on the train, for example. You know, they use the avatars to get the person who wrote the report to sort of present it in video format. And rather than, getting the human to stand in front of the green screen and, record it every time they write a report, which is expensive and takes their time, you can get the avatar to do it. Now, you can also think of negative use cases, which have also happened. So there was a finance professional in Hong Kong who was invited to a video call with what he thought was his CFO. Now, interestingly, it wasn't just the CFO, it was a whole set of other employees. Now, and it's still unclear to me whether the other employees were real or whether they were also AI avatars. But basically, the CFO said, we're buying this company. I need you to transfer $25 million to the account number that I'm going to email you later. And so, especially given this was 2024, so this is early days, the professional thought, well, it looks like the CFO, sounds like the CFO, moves like the CFO. So, I trust it. I'm going to send the money. Especially, as I say, if you've got other people on the call as well, and maybe they're avatars, but that then gives you that sort of pressure, right? That peer pressure from other people. So it feels like, okay, I have to take action because there's all of these people that all say, we're going to do this, and now I have to do it. So this kind of thing perhaps gets around some of the controls that were maybe good enough in the past, which are perhaps not good enough now. I mean, the most obvious one is, my voice is my password, this kind of stuff. So that should have gone, at least a year ago, given you only need 15 seconds of someone's voice to clone it. And there are also systems where you log in with your face and it says, smile for the camera or move your head to the side or something like that. And all those systems are also defeated by this kind of technology. So yeah, real challenges to security systems and changes that need to be made. Now, just to say, Arbaz, thanks for your question. Let me come back to your question about which sector is going to be less affected by AI's development. Let's come back to that at the end once I say a bit more about how it works. Now, the last one I want to talk about in terms of big picture is, of course, agentic AI. So this is the trend towards giving AI agency. In other words, the ability for AI to go off and take actions in the real world, experience the consequences of its actions, and then carry on going from there. So just to sort of show a video about how simple this is. So on the right-hand side is a video of someone using Claude Code to book a flight. So they give it a prompt. They say, I want to go to Tokyo, this date, use Google Flights. And basically what it does is the agent has the ability to open a web browser. And so the AI basically controls the mouse and the keyboard. And so it clicks on what it likes, it writes, it types in whatever it likes. And, it's as simple as that, right? Like you give access to an AI to have the same user experience as humans do. So whereas previously, you'd have a whole system of APIs and all the rest of it to try and teach the computers to talk to each other. But we already have a system for people to access databases and information. It's just the internet and a web browser. So you give the AI the same access. And now it's good enough that it can understand what's on the screen. It knows where to click. It knows what to type. And it just takes over and takes actions. Here's an example in banking of this. So there's a company called Do Not Pay. They started out helping people fight against parking charges. So they had these like pre-written like letters that you could send to dispute parking charges. But now, they're embracing AI tools. And so, I just went on their website. One example was they'll use their AI to help you to do a chargeback. So, you want to dispute a charge, whereas previously you need a bit more, well, it needs some level of expertise in order to actually dispute that. Now you can just talk to the AI and then the AI will do it for you. Now, also what I find interesting is that even if it's not very good, it still has implications for institutions. So in this case, do not pay has been told by the Federal Trade Commission in the US that they're not allowed to sell their lawyer as the world's first robot lawyer because it's not as good as a lawyer, right? But even if even if it's not as good as a lawyer, it still causes implications because, you get all these people getting AI to, dispute charges and write legal notices and all the rest of it. And, they get sent to the company, and then the company has to work out, is this actually nonsense or not? And that requires expertise in order to do that, right? So, in order to realize that a legal threat is actually nonsense, because it's written by AI and the AI hasn't actually cited the right cases, you need an expert to recognize that, right? To a non-expert, it will seem very plausible that this stuff is true, and it will write it in a very plausible way, right? Like the same thing as showing this picture of Cambridge University Judge Business School at the beginning, which feels like a very good picture. It's just not factually true. So even if it's not factually true, it still has all these implications because now I need a, there's a potential for a deluge of people using AI to, do all sorts of complaints and things that now I need to bring in real human expertise to spot, because the AI probably can't spot it because it's written by AI. Yeah, still issues, even if it's not very good. Just respond to this question: is AI able to detect content created by AI? Yeah. So again, if it's videos, yes. If it's images, yes. If it's text, no. Is the very short answer. It depends how accurate you want it to be. If you want it to be sort of 85% accurate, then maybe it can detect text written by AI. But if you're looking for anything close to 100% accurate, then it's just not there. Yeah, like in my case, if I want to say that a student has used AI to write their essay, then I can't accuse someone of cheating with 85% accuracy, right? I need 100%. So it depends on the accuracy that you need. Now, just to say something about the progress of these agentic AI systems. So if you just concentrate on the one on the left for now, how do we know that agentic AI is getting better? Essentially, what machine learners do is they put tasks in order of how long it takes a human to do them, right? So you've got tasks that takes humans 5 seconds, 5 minutes, 5 hours, 5 days. And you give those tasks to AI and you say, which of those tasks can the AI do reliably and which ones do they make mistakes on? And that gives you a benchmark of, this model that just came out can do tasks that take humans 2 minutes or 5 minutes or 5 hours. And this other AI, can't do those tasks. So this is what has been happening over the last few years. So GPT 3.5, right, ChatGPT could do a task that takes humans like seconds, but not a task that takes a human minutes. But you can see this exponential curve here, and this exponential curve reflects doubling every 7 months. So GPT-5 can do tasks that takes a human about 30 minutes. So what that would mean is in 7 months, you expect it to be able to do a task that takes 1 hour, and then 2 hours, and then 4 hours. You can see how quickly you get to a point where these things can really act like employees, right? Because I can come in the morning, talk to my AI and say, here's what I want you to do today, right? And it can go away and do a task that takes a human in 8 hours. and I can have multiple AIs, right? I can have my CMO AI, I can have my CFO AI, and I talk to the CMO and say, what adverts have you been running? You know, what's happening with the marketing? What have you tried? I talk to the CFO and say, how's the money going? And then the marketing AI talks to the finance AI, right? They have a conversation with each other. And the marketing one says, you know, we want to run this campaign. Do we have the money? And of course, the finance one says no, but you know, maybe later. So there's that going on, right? And then my job starts to really change because my job is to work with all these different AIs, and rather than kind of supervise them like an intern, like you kind of have to do now to make sure are they really doing the right things. In the future, you know, I can sort of supervise them like an employee, right? I can give them much bigger goals. I can say, you know, here's what I want you to achieve today, rather than I want you to do this task and then this task and then this task. Now, I show this one because what scares me here is that just now I said it was doubling every 7 months. Actually, in the last year, it's been doubling every 4 months. So 4 months from now, you're expecting, you know, an hour, then 2 hours, etc., etc. So it's going even faster than it was. So again, for me, this backs up the point that, you know, things are not only changing fast, they're in some cases changing even faster than they were before, right? Like the speed is only going up. Now, last one on this, there's also the issue, you know, to look out for. What about what might emerge from these AIs having conversations with each other and doing things together? So there was this nice academic paper that came out quite recently about what about if you get an AI to set prices? All right, so large language model, you know, you can give it a good prompt and it will have a go at setting prices. And then they got multiple AIs to set prices, right? And pretended to be from different companies. And the question was, what would the whole system do? And what they found was that if I take this chart on the right, you know, this is just a sort of a demonstration. But basically, the price that was set by these algorithms went above the competitive price. So they were basically working together as an oligopoly. And this was a surprise because it's not like the algorithms were prompted to do this. They were just prompted to, you know, your goal, try and make most money, you know, this kind of stuff. It wasn't a prompt like, you know, try and cheat the system or something like that. But they just naturally started working together and ended up pricing higher. So why was that? And this bit I found fascinating. So apparently it was driven by a desire of the large language models to avoid price wars. So I'm guessing, you know, in the training of large language models, you know, we try to train them that wars are bad, right? Therefore, you know, don't say good things about wars, you know, don't start wars, you know, this kind of stuff. And therefore, a price war is another thing that's bad, according to, you know, its training. So, you know, as a group, they avoid these price wars and they all work together and they end up increasing the price. So it's a very complex world, you know, not just what one agent might do, what one AI might do, but when they start talking to each other and, you know, what might emerge out of that system is very unclear. Okay, just reading questions in the chat. So, Rinal, can AI make financial model read PDF, fill the Excel, sector future do projection for next 2-3 years? Yeah, it can do that kind of stuff. So, well, like probably, well, Claude and Google are probably best at doing that kind of thing. I've seen like demonstrations where people have got it to fill in Excel sheets and fill in all the formulas and all the rest of it and do projections. You can also try Perplexity. Perplexity, it has a kind of a labs version where it will produce very sort of clever financial things. It will also, well, it does them in Python, however, so it writes code and then runs the code and then shows you the results of the code. So it will run simulations and that kind of stuff in Perplexity as well. Next question. So someone says on their iPhone, AI tends to provide responses sometimes high quality, but not necessarily consistent. So sometimes the quality deteriorates. Why does it happen? All right, great question. Let me cover that in the last minutes of this. So let's slide. All right. I promise you I talk about how does it work, and by seeing how it works, it becomes clearer why does it do this kind of stuff inconsistent. Very briefly, all of the large language models use the same system, right? So even though ChatGPT is the only one that has GPT, all of them are GPTs, right? They're all generative pre-trained transformers. They're generative because they create new content. They're transformers because they use the transformer algorithm, which was published about by Google back in 2017. You can go and read all about the transformer. And they're pre-trained. So pre-training is basically the idea that instead of training the algorithm to do what we need it to do, we will try to teach it something fundamental. And when it learns that fundamental task, then we'll find it useful for other things. So it's a bit like teaching a child. You know, at the beginning, you teach them to count from 1 to 10. Now, counting from 1 to 10 isn't particularly useful by itself, but you use that as a platform to then, then they can learn other things on top. Now, the fundamental task for a large language model is what word comes next in a sentence. So you effectively, you feed it lots of textbooks, lots of things written by humans, and you get them to predict what word comes next in the sentence. That is no one's problem, right? No one's sitting there going, I've got a problem at work. I need to predict the next word in a sentence. But if you can predict the next word in a sentence, it turns out you can do lots of other things that are useful. Imagine the sentence is, the bank collapsed because, right? In order to continue that sentence, it has to know something about finance and crises and this kind of stuff. If the sentence is the customer was annoyed because such and such happened, so the bank employee told them what, right? And then the AI, can it predict what the bank employee would tell the customer who's had a complaint, right? So if it can do that, it turns out it can also act like that bank employee, right? Like talking to the customer and helping them to feel better. So predicting the next word is very powerful because you can use it for all sorts of things. So let's be ChatGPT briefly ourselves. What's it going to write next? The best drink in the world is what? Again, just write in the Q&A box. And then we'll try it. All right, James, water. Lots of people saying water. Very healthy people. I've also got some water here. Beer. Good answer. All right, so maybe Shamir, maybe it depends who is asking, right? So maybe it doesn't answer the question. Maybe it kind of avoids and says, well, it depends, right? Reese says fresh water. Maybe it says champagne because that's prestigious. Maybe it says tea because it knows I'm British. Let's see what it does. So I said, continue the following sentence. The best drink in the world is, what's it going to say? Is the one that tastes perfect in the moment you need it most. Very lovely. Now, if I refresh, it's going to give me a different answer, right? The one you're drinking at exactly the right moment. So, you know, you ask this question, right? It's giving you inconsistent responses. Why is that, right? I've asked precisely the same question, but it's given me a different answer. And the reason is when it's predicting the next word, this is what it does, right? So you ask your question, what is a large language model? It starts producing text, and every time it produces a word, what it does is it takes every possible next word, it ranks them from most likely to come next to least likely to come next. And then it takes one of the top words, puts it into the sentence, and does exactly the same thing again, right? What word's going to come next, ranks the words, takes one, puts it in, and that's all it ever does, right? Whatever you think that Gemini, ChatGPT do when you ask a question, it doesn't do that. The only thing it does is predict what word comes next, just over and over again, right? So if I run the animation, you can see it's just taking words, predicting, and putting them in. That's how it answers your question. So if you ask a factual question and say, what is the capital of France? What you might imagine is that it goes to a database of facts inside ChatGPT, finds France, you know, goes into it and finds the capital city of Paris, and then it uses that information to answer your question. But that's not how it works. When you say, what is the capital of France? It goes, well, normally when people answer this question, the first word they use is what, and then capital of France is Paris, full stop. Right? That's all it's doing. It's just predicting words one at a time. Now it happens to get the right answer in this case, right? It says Paris, and that's because it's seen lots of examples of people saying the capital of France is Paris. So it's very likely to say Paris. But if you ask it to do some sophisticated financial thing that it hasn't seen many instances of in its data set, maybe it happens to predict different words, right, each time you do it, and therefore you end up with inconsistent responses. So that's a key thing I want you to take away about how it works, right? It is not factually based. It's not a factual machine. It's not like a calculator following this logical process. It's going probabilistically, what would a human write next? And that's still very powerful, right? Because you could say, you know, pretend to be a finance professional, pretend to be an actuary with 30 years experience, and now answer my question. And so, you know, and it does a very good job of pretending to be that actuary with 30 years experience, right? So it's very powerful, but it's still not factually based, right? The whole system is not set up to be factually based. Okay. Now, there's one last slide I want to show to finish off, which is a bit about the culture to be successful. So let's get here. So I've talked about the technology, like what it fundamentally is. This is what comes out of that, right? In order to be successful using Gen AI, you have to be experimental to some extent, because OpenAI or any of the others, they did not create their technology to solve your problem, right? Previously, you make a machine to solve a problem, right? You make an algorithm to solve a problem. This is an algorithm that is solving the problem that no one has, which is what word comes next, right? So it's set up to be generally intelligent. Does that mean it can solve your problem? Only you can find out, right? You've got to try it yourself. Does it work in your organization for your particular task? You've got to try it. You have to some extent, be willing to take a risk, because this thing is inherently unreliable and chaotic, right? But the goal here is not zero risk, right? Because it's not that kind of algorithm. But how do you set up a system to manage the risk, right? So it's more like bringing in a new employee, right? People make mistakes, right? There are no sort of zero mistake employees, but you put a whole system around them: accountability, controls, auditability, escalation path, and the same thing applies to the AI, right? So I talk to finance organizations who go, well, yeah, but this thing is inconsistent and it makes mistakes, and so we're not going to use it to solve this problem. And then I say, well, what are you going to do instead? And they say, well, we're going to employ a human. And I'm like, well, what, your humans never make mistakes? So you know, the mental model is more like, it's like bringing in a human, and you need to set up a governance system around them. And then finally, agile. I've said a few times, right? It's changing fast, and this is the worst AI you'll ever use. It's only going to get better. It may get better faster than it's been getting better in the past, which is already very fast. So for you to use this, you're going to have to be willing to iterate, try things, see if they work, fail, try new things. Ongoing learning as the technology gets better. We showed those videos and how it's quickly improving. What may not have worked in the past, suddenly a new model comes out, solves that problem. So ongoing learning and use of the new ones as they come, and the willingness to change. You don't want to be the person that says, I'm not changing the way I do things, because the way I do things, I've been successful doing this for the last 30 years. Because the technology is getting better. So again, even if it can't solve your problem today, right? If you've tried it a year ago and found, oh, it's not very good, that doesn't mean that the technology, won't solve it this year or the next year. All right. I'll stop there. Other than to sort of highlight, these are three things that financial institutions are not known for, right? Being experimental, risk-taking, and agile. And I think that brings a real risk that financial institutions look at this stuff and they go, we're not going to apply this in our business because we're not experimental, risk-taking, and agile. And that leaves the door open, whether it's to fintechs, whether it's to startups, I don't know, but it leaves the door open to others to come in and sort of start taking over. All right. I should stop there because I'm past the time. Back to you, Mike, I think.
Wonderful. Thanks, David. Thank you so much for the session. Sincerely appreciate that. I know I learned a lot, and I'm sure everyone else did as well. So I put in the chat a link to the program website. If you'd like to learn more and connect with us, the best way to do that is to click on Profile Review on the program website. You can submit a CV and book a time to have a chat with me to discuss if the program might be a good fit for you. So hopefully we'll hear from you soon. Thanks again to everyone for attending today, and thank you so much, David.
Can I do with one last answer to Arbaz's question, because I promised I would. It was, which sector is going to be the least affected? My advice is, if you're trying to avoid being replaced by AI, go into AI governance, because however good AI gets, we're going to want humans to be in charge. So AI governance is a good place to be.
There you go. Career advice to wrap up. Thanks, everyone. Thanks, David.